Today I'm going to be talking about identifying and using the focus of the parabola. This is our second day of this section. So what we're going to be doing is writing an equation of the parabola with the given characteristics. So I give you a focus of 2, 3, 0 and a directrix of x equals a negative 2/3. Now we have to be really careful because we have to decide, is this an x equals or a y equals equation? Well, since the directrix is an x equals, our equation is going to be an x equals. So let's write that down. We have an x equals 1/4 p y squared. So we need to know our value of p. Well, our value for p is our focus value. So our p is 2/3. So we're going to plug in and solve. So x will equal 1/4 times p, which is 2/3, y squared. Simplify, 1/8 y squared. So that's going to be x equals 3/8 y squared. And we've got our equation. Much easier than before. Now our next one, I give you the vertex of 0, 0 and the directrix of y equals 8/3. So this is going to be a y equals 1/4 p x squared. So we need to find the value of p. And the value of p is always the opposite sign of the directrix, so this is going to be a negative 8/3. So let's plug in and solve. So y will equal 1/negative 32/3 x squared. So y will equal a negative 3/32 x squared. And there's our answer for that equation. These are really nice and simple, especially when the vertex is through 0, 0. Okay? I've got one more example in this area. Vertex of 0, 0, focus of negative 4, 5, 0. Since the p is in the x, then this is going to be an x equals. Okay? So we have an x equals 1/4 p y squared. We have to find our value of p, which is a negative 4/5. So let's plug this in and simplify. Negative 16/5. So x will equal negative 5/16 y squared. So those are pretty quick and easy as long as you pay attention to if it's an x equals or a y equals. And then you can just plug in and solve after you find your value of p. Now these are all when the vertex is 0, 0. But what happens when the vertex is no longer 0, 0? It has been transformed. It's a transformation. So now we're writing an equation of the parabola with the given characteristics, and the vertex now has moved. Okay, so it gives us a few pieces of information. It does open right, so we're going to sketch this. So it opens right, so now we know it's an x equals since it's opening right. The vertex is at 2, 4. And that vertex is 1 unit from the directrix. So the directrix is going to be over here, of course. And 1 unit away is going to be x equals 1 because the x value of the vertex is 2 and 1 unit away is 1. So what we're going to use is we have a new vertex form for this. I'm going to write this down for you. And then we know it's an x equals. So what we're going to use, this is brand new, x equals 1/4 p times y minus k squared plus h, where our vertex is our h and our k, and our directrix is going to be x equals h minus p. I'm going to put all this information in one place at the very end. Okay, so we have all these pieces of information. So we need to know our vertex, which is our h and our k, to write this equation, and we need to know our value of p. Well, if we look at this, we have our vertex, so that's our h and our k, but we need to find our p. Well, if I know that my directrix is x equals 1, I can put a 1 in for x. I know that my h is 2, and now we can solve for p. We can subtract the 2. Negative 1 equals a negative p, so p is equal to 1. So now I have my p, my h, and my k. My h is 2, my k is 4. Now we can use these pieces of information to plug it back into our original. So our equation is going to be x equals 1 over 4 times p, and 4 times 1 is 4, y minus k, which is 4, squared plus h, which is 2. And now we have our final equation for that one. So be really careful if you identify it as x equals or y equals. Let's try another one of these. This one, I give you the focus and the directrix. So let's graph this real quick to see what we've got here. So we have a directrix of x equals 3. And then a focus of negative 7, 2. Okay, so we know it's going to be opening to the left because the focus is to the left. So it's going to be opening like this. We need to find our vertex. We don't know what that is. Okay, so it's opening to the left, so we know it's an x equals. So we can use the x equals 1 over 4p y minus k squared plus h. Our vertex is hk. And my directrix is x equals h minus p. So this is another x equals, okay? So to write this equation, we need our h, we need our k, we need our p. Well, our h and our k is a vertex, and we don't know our vertex, so we've got to figure it out. And if we remember the properties of the vertex and the relationship it has between the focus and the directrix, is that it is in between the focus and the directrix. It is halfway. So what we can do is we can take the x values of the focus and the directrix, negative 7 plus 3, and divide by 2, and we get a negative 4 over 3, and we get a negative 2, because it's halfway in between the focus and the directrix. So the vertex is going to be at negative 2, and you know that the vertex and the focus both go through the axis of symmetry, and the axis of symmetry is y is equal to 2, is the y value of the focus, so the y value of my vertex is also going to be 2. So this is my h and my k. My h is a negative 2, my k is a 2. All right, and now we can use the directrix to find out p. We know our directrix is x is equal to 3. Our h is a negative 2, solve for p. So p is equal to negative 5. Now that we have all three pieces, we can write our equation, which is going to be x equals, and 4 times negative 5 is negative 20. Negative 1/20th y minus k plus h, which is a negative 2. So there's our equation for that one. Okay? Now, in our next example, we're working backwards. We're working backwards for this one. I'm going to identify the vertex, the focus, the directrix, and the axis of symmetry of the equation of this parabola. So I'm giving you the equation, and now we have to find the information from the equation. Okay? So I'm going to write down everything that you need to know for this. And this is a y equals. And we're going to skip the transformations for today, describing the transformations. So if we have a y equals, let me make this larger. If we have a y equals, our formula is 1 over 4p x minus h squared plus k. And then you need the vertex, the focus, the directrix, and the axis of symmetry. Okay, so for all of these, I'm going to show you how to get them. Our vertex is at hk. Our focus is at h, comma, k plus p. Our directrix is y equals k minus p. and our axis of symmetry is x equals h. So we're going to use all of these pieces to write these down. So what we need to know from the equation is what is our h, what is our k, and what is our p. Okay. Well, if we look at this, our h is a -2, our k is 1, and our p is going to be a -1. Because to get to 1/4 to a -1/4, we have to multiply by a -1. So let's start plugging this in. Our vertex is at a -2, 1. Our focus is as a -2, k plus p. Well, k plus p is 1 minus 1, so it's 0. Our directrix is k minus p, so it's 1 plus 1, which is 2. And then our axis of symmetry is x equals a -2. And now we have all of our pieces of information, and we are good to go. Let me show you an x equals. All right, so same thing, vertex, focus, directrix, and axis of symmetry. So I'm going to write all this information down for you again. So for the x equals, we have an x equals 1 over 4p times y minus k squared plus h. And we need to find the vertex, the focus, the directrix, and the axis of symmetry. So the vertex, as usual, is hk. The focus for this one is going to be h plus p comma k. Our directrix is x equals h minus p. And our axis of symmetry is going to be y equals k. So we need to find out our h, our k, and our p. So our h and our k for this one, our h is a -1. Our k is a -5. And our p, well, what we can do is we can set these equal to each other to figure it out. We can do 4 equals 1 over 4p, cross multiply and solve. P is equal to 1/16. We can do that trick. So p is 1/16. All right. So now let's plug this in. hk is -1, -5. H plus p for our focus is a -15/16, -5. Our directrix is h minus p, so that gives us x equals -17/16. And then, of course, our axis of symmetry is y equals a -5. So you definitely need to work with that. Having that in front of you is really going to help you on your homework.